Hi, I'm Chem's best friend. I make chemistry easy. I'm a graduate of MIT, and I have more than 17 years of experience teaching AP chemistry and chemistry classes. Please like and subscribe to my channel. And if you are interested in private tutoring lessons, the information is on the screen. Hello again. Today we're going to learn about double replacement reactions, and especially precipitation reactions, the ones that form a solid. So, you ready to learn? Let's go to my screen. So double replacement reactions are when the two cations switch places. So here we will go. We have an ionic compound, A and B. You have a cation and an anion. Cation is A, anion is B. Then we have another ionic compound, CD. We said that it's Adam and Barbara dancing, and Charlie and Diane. And then on the dance floor, during the dance, the two boys switch places. So in our double replacement reactions, the cations will switch places. Let's look at the beautiful picture. They form beautiful precipitates. They look like powder, and they can have really nice colors, depend on the type of compound you have. So, I think, enough talking, let's actually see an example of a double replacement reaction. Let's look at a video between a reaction between two solutions, silver nitrate and copper 2 chloride. So here we have in a test tube a solution of silver nitrate, and I'm going to add a solution of copper 2 chloride to it. Silver nitrate is a clear solution. It looks like water. And look, the solution coming out is also clear. And as soon as the two solutions touch, you have this cloudy precipitate. You can see it actually looks pretty beautiful. And wow. And there you go. It was a beautiful example of a double replacement reaction. So now, let's actually learn about it, what happened. Here is our quick picture to remind us what happened. Let's write what we saw. We had silver nitrate, and the solution was clear. There was nothing there. It looked like water. That's why it's AQ, aqueous. We added a solution, another clear solution, of copper 2 chloride. That was also clear. That was also aqueous. And then what happened? Well, in our double replacement reactions, the cations switch places. So we had silver chloride and copper nitrate. But now I have to quickly make sure my compounds that I formed are neutral. So silver has a +1 charge, chloride has a -1 charge, so my compound, silver chloride, is good. But my compound of copper nitrate, copper has a 2+ charge, nitrate has a -1 charge, so I need 2 nitrates. This has to have 2 here. Now, I need to balance my reactions. I have 2 nitrates, I need to have 2 here, and I have 2 chlorides. So I need to balance my reactions, and now it formed a precipitate. It formed that cloudy substance, the powder was swimming in water. Which one? Is it silver chloride that's my precipitate, or is it copper 2 nitrate? Well, in order to decide, we are going to look at our solubility rules. They tell us which substance is a solid. Let's have a look here. The easiest one to know is that nitrates, all of your nitrates are always soluble. So that will be AQ. And here is chlorides. Chlorides are soluble except with heavy metals. What are the heavy metals? They are with silver, lead-2, or mercury. Oh, let's go back. Here is silver and chloride together. So this must be my solid. What I would like to do next is to actually make sure you understand this reaction and to understand what AQ means. AQ means dissolved in water. But how do ionic substances dissolve in water? Do you remember? They have to dissociate into ions. So I would like to draw a picture to really show you what's going on. So first, in our first beaker, we had a solution of silver nitrate. Let's make our silver red. So here will be our red silver. Let's make our nitrate blue. So here is silver nitrate, but we had two of them, right? We have to balance them out. Oh, and we have to have nice water level. We have to draw a picture. We had one more. So look at this. I'm drawing my ions separately. They're swimming by themselves. Everyone is swimming by themselves. So the red dot is my silver ion. Blue one is my nitrate ion. So the blue one represents all of my polyatomic ion. It represents 1 nitrogen and 3 oxygens together. Now we're going to have in our second beaker, we had a copper swimming. So copper, we can make copper green. And we have to have chloride. Let's make chloride orange. Or maybe bright yellow would be better. Here is our 2 chloride ions swimming. Okay. And what happened? So we have our copper, 2 plus chloride. And we mixed the 2 solutions together. What did we get? Well, we got silver chloride. So we have, here is our silver and chloride. And look what I'm drawing. I'm drawing them together touching. They formed that solid. And to really emphasize it, I am going to put it not only together, I'm going to put it in a box to really emphasize that this formed a solid. And what else is in my beaker? Well, the nitrates are swimming around. And the copper ion is swimming around. So here is a beautiful picture to represent cartoon-like way what is happening in this reaction. The picture is great, and it really shows you what AQ means. Separated, dissociated. So now, based on what we see in the picture, let's write our chemical reaction. We're going to call it complete ionic reaction. So let's go to that new page. And we have, let's write what we saw in the picture. We had 2 silver ions swimming together. Silver is always +1. We had 2 nitrate ions swimming together. We also had, now we're going to the other beaker. We had a copper ion swimming, and we had 2 chloride ions swimming. So this right here is what happened in my 2 small beakers. And then which ones combined? What was my solid? Silver chloride was my solid. It formed silver chloride plus, well, what was swimming in my beaker? What was quickly swimming? What was swimming was copper and nitrate ions were swimming by themselves after the reaction. They were swimming just like before. So I have copper ion swimming plus my 2 nitrate ions are swimming. What I just wrote, it's called, this is called complete ionic reaction. Let's look a little closely. What is the same before and after the arrow? What doesn't change at all? Have a look. There is my copper ions is this before and after the arrow are totally the same. And what else? My nitrate ions, they are the same before and after the arrow. Let's look at the picture. My blue spheres were swimming by themselves in a beaker, in a first beaker, before the reaction. Right here, the blue spheres are swimming by themselves. And after the reaction, they are still swimming by themselves. It's like nothing happened. And the green sphere, the copper ion, was swimming by itself before the reaction. And right here, after the reaction, it's also swimming by itself. It's as if nothing happened. So they were there. They watched the reaction happen. We call these spectator ions. They were there in the beaker. They watched the reaction happen. Nothing happened to them. It's as if I told you that I have tickets to a great basketball game. And I'm going to take you to the basketball game. You are all excited. We're going to the arena. But the day before the basketball game, I decide I'm not going to take you, but I'm going to take your friend instead. You would be upset, but the game would happen. The game would happen regardless of who is sitting in the stands, whether you or your friend. So you got to imagine the whole arena is the whole beaker. When we have spectators who watch the action, the players. Who were the players in my reaction? When you're going to watch a basketball game, the camera zooms in on the playing field. Who am I on the court? Who are my players? Well, it seems like what changed? Right there, silver ions in red and chloride ions were swimming by themselves before the reaction. But now after the reaction, right there, they formed that solid. They formed the precipitate. Let's write then. Let's write our reaction without the spectators. Let's zoom in on the playing court, and we're going to call it net ionic reaction, and write actually what happened. So what happened? We had 2 silver ions reacted with 2 chloride ions, and they form a solid, silver chloride. You can feel free to erase the 2. Everything is multiplied here by 2. We do not need that for a balanced chemical reaction. So it's my silver and chloride combined to form silver chloride. That's my reaction. Okay, we're going to quickly write the steps. How are you going to deal with writing double replacement reactions? There's 4 steps to follow. This is what we did first. Number 1, you're going to switch cations. Remember, we first switched the cations. We first switched, when we were doing our reaction, we switched right here. We switched silver and copper to ions. So switch your cations. Number 2, after you switch, then you're going to make your products, your new ionic compounds. Make sure the products are neutral. Make products neutral. This is where I was thinking about the charges, and I had to quickly fix things. So do you remember? I first wrote copper nitrate, and then I realized copper is 2+, nitrate is -1, and I had to have 2 nitrates. Oh, and this was my AQ. So make your products neutral. Number 3, you're going to balance the chemical reaction. Number 4, you're going to look at your solubility rules and predict what is the solid. So you're going to determine the states. And by this means what's solid, what's aqueous, maybe liquid or gas. So you're going to determine the states. How? You're going to look at solubility rules. Okay. I think you should try a reaction. Let's try it. I would like you to write a chemical equation for a reaction between potassium iodide and lead 2 nitrate. I didn't write the chemical formulas for these compounds because I would like you to know them. So here's a picture. They were both clear solutions, and when they touch each other, when they mix, they form this beautiful yellow precipitate. What is that yellow precipitate? So I would like you to write a molecular form, which is the overall reaction. Molecular form is that first equation we wrote over here. The first equation, I would like you to write a molecular form. I would like you to draw a picture to make sure you understand. I would like you to also write a complete ionic equation, and I would also like you to write a net ionic equation. I know I'm a tough teacher, but it's for your own good. You can do it. So please pause the video and do all of these steps. Okay, how did you do? Let's check. Well, here it is. Potassium iodide. What's the formula for potassium iodide? It's Ki. What's the formula for lead nitrate? PbNO3 2. Lead is 2 plus, nitrate -1. And we're going to switch the cations. From the lead to iodide and potassium nitrate. Double check your charges to make your compound neutral. We need 2 iodides here to balance the charge of lead. I looked at solubility rules, and it's lead to iodide that's a solid. Here is a nice picture, and I included a key on the side, what is what. And here is my lead iodide as my solid. And here is my complete ionic reaction and my net ionic reaction. So the very, very last thing, what is the driving force of a double replacement precipitate reaction? In a previous video, we wrote 4 things which are the driving forces. They can be formation of a solid, formation of a liquid, formation of a gas, or transfer of electrons. Well, what happened in these reactions? Both examples you saw, the driving force of a double replacement precipitate reaction is formation of a solid. That's why these types of reactions happen. So I hope you learned how to write double replacement reactions. I hope you in your head understand the cartoon way of how they happen, why they happen. And thanks for watching the video.